data science, when we are talking about it, we know that there are multiple formulas that are involved in the data science. So as part of the formulas, when I'm talking into it, we might encounter the formulas from statistics, we might encounter the formulas from trigonometry, we might encounter the formulas from mean, median, mode, deviations, whatnot, because all these things are required in order to perform some predictions, in order to perform some future trends about the business or about the data that we have it. So on basis of that, we prepare visualizations, we prepare reports and everything as part of the client's requirements in the project. We know that we have mean, we have the average, we have median, we have modes, which we have seen recently. But are you aware that what exactly is a variance and how is that being calculated mathematically? Hi, I am M. Asif Hussain from KnowHow Academy. What are we going to learn in this video? We are going to learn and understand what is a variance in data science. We are even going to learn what are the different formulas we have in variance, such as population variance, we have sample variance. We are going to learn the practically with some data with these population variance and sample variance. So by the end of this video, you could able to calculate the problematic part of the data science which we have it as part of variance using the formulas that we are going to learn in this video today. So watch till the end. My dear viewers, when I'm talking about a variance, okay, it's in a variation, in a very general terminology that we will be using it as part of our day-to-day life. So where we go with the variation is nothing but, so we are going to see what is the variation between this particular business and this particular business, this sales to this sales, from this currency to this currency. So we have a lot of examples if you would like to talk about. So here when I'm talking to you about the variance, so if I just walk you with the very easy way of understanding it. Okay, so variance. So in this variance, we have two types of data that we would like to discuss it with here. So one we have is nothing but the population data. Okay, one we have the population data. So when we are talking about the population data, it is very appropriate. Okay, it is very appropriate result, that it is 100% appropriate result that we will get it with this particular population data, because we are not going to have multiple samples out of it. But we have some other data called as sample data. Okay, we have something called as sample data. Depending upon the number of samples, we get number of values. Okay, so for a very easy example, if I would like to take, whenever we hear the word called sample, we will understand about the blood sample. Okay, so from 10 different people in an organization, we are collecting samples, we will get 10 different values. If you are collecting sample from only one person, we'll get only one value, as simple as such. So what's happening here is that the population data that we are considering, this is 100% sure that the measures that we are calculating are appropriately correct. Okay, so now what we are going to get with the sample data, it's an approximate value, not sure but approximate value that we are going to get it from this particular sample data. So now if I would like to talk to you about the formulas, one we have is a population formula, one we have is a population formula, and another one we have as a sample formula. Okay, we have two types of formulas here that we should specifically focus all upon. So when I'm talking about a population formula, if I just walk you with the population formula, we generally denote it with sigma square. We generally denote it with the sigma square. So what this sigma square is doing, so sigma square equal to, here we have, okay, sigma n. So what we have here, we have sigma square equal to summation of n I equal to 1, n I equal to 1, xi minus mu. Okay, we will get consider mu here, mu whole square. Okay, mu whole square divided by n. Okay, this is the formula that we generally consider when we are talking about a population formula. So what exactly it is telling? Sigma square, we will consider the square roots here. So sigma square equal to sum of the squares difference we are considering. So that's what we have it here. Sum of the squares difference that we are considering between what? Between the observed values and the population mean. Between the observed values and the population mean divided by total number of observations, that where we consider n here. Okay, so that's what it is, population variance formula. So now if you would like to talk about the sample variance formula, if you would like to talk about the sample variance formula, we generally denote, as it is a sample, it's very clear that we consider S square, okay, sample square, equal to the same thing that we are considering here, summation n I equal to 1, okay, summation I n is summation n I equal to 1. Here what I am doing, xi minus x bar whole square divided by n minus 1. So that's what it is a different here, n minus 1. So what exactly it is telling here? It is telling that it is the sum of the square difference. So this is the sum of the square difference between what? Between the observed sample. Between the observed sample. So it is nothing but sum of the square difference between the observed sample value and the sample mean, okay, which we are dividing it by total number of sample observations. This is very important. So what we are doing, it is just the total number of observations, but here what we are doing, total number of sample observations minus 1. Okay, that's what we are considering it here as a sample variance formula, and this is nothing but the population variance formula. Okay, right. So we have got the formula, but it is little bit difficult in order to understand. So let's understand it with a very simple example. Okay, so for this what we are doing is that, let us consider that we have a population data. Let us consider we have a population data. Okay, we have a population data such as 1, 2, 3, 4 and 5. Okay, we have a population data such as 1, 2, 3, 4, 5. So now first let us find out the mean of it. So when I'm talking that we have to find out the mean, it is very simple. It is very simple. What do we have it here? 1 plus 2 plus 3 plus 4 plus 5. It is nothing but an average that we are seeing it, right? So 1 plus 2 plus 3 plus 4 plus 5 divided by total number of intervals that we have it 5, which is equal to 3, right? So 3.00 let us consider, which is equal to 3. Okay, so now in the same way, if I would like to find out the population variance with the same data, I would like to find out the population variance. So what is the formula here? Summation of, sigma of ni equal to 1 xi minus mu whole square divided by total number of observations. So for this, if I would like to calculate, it will be sigma square equal to, we have 1 minus 3, okay, which is mean, 3 is mean here, okay, 1 minus 3 square plus we have 2 minus 3 square plus we have 3 minus 3 square. This is the observation that we have to see. 3 minus 3 square plus 4 minus 3 square, 4 minus 3 square plus 5 minus 3 square, 5 minus 3 square, which we are going to divide it by 5. So again, which we are going to get 2. Okay, so this is nothing but the population variance with the example that I am showing it to you. In the same way, if I would like to find out, the sample variance, okay, if I would like to find out the sample variance here. So what is the formula? Summation n I equal to 1, where we have xi minus we have x bar whole square divided by total number of sample observations minus 1, right? So the same thing we have it here. So the same thing I am considering, which is 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square, which is a very interesting observation or mean I can consider plus 4 minus 3 whole square, okay, plus 5 minus 3 whole square, 5 minus 3 whole square divided by, here we have 5, but now what we are going to do, we are going to n minus 1, which is 5 minus 1, which is 4, and the answer here will be 2.50, and the answer here will be 2.50. So with this, what you can see here, we can see that the mean we have 3. By getting the mean, then only we are able to calculate the population variance. We are even calculating the sample variance. But if we compare the population variance with the sample variance, the sample variance has have the upward value, I mean the highest value when compared to the population variance. Okay, so why we are getting it a little bit high when compared to the population variance is that it will reflect the higher potential variability. Okay, it will reflect the higher potential variability. So with this, what we can consider that the sample variance that we are getting it, on basis of that we could able to go and predict some output which is based upon the project. Okay, for example, if we are stuck in some future predictions, what might happen in that particular sales, when the stock might get down, so what happen if we invest on that particular time, then using all these kinds of formulas we can go and calculate the future prediction or future or how much loss or profit we are going to get at. That's what we use it here. So this is how you have to use the formula of population variance, sample variance, and you have to calculate it. So my dear viewers, in this video we have seen what is a variance, what are the two types of variance we have, population variance and the sample variance, its formulas with some examples. Thank you for choosing KnowHow Academy as your source for IT knowledge. We are always here to help you to navigate the tech world. If you have any questions, do not hesitate to reach out. It's been a pleasure sharing this information with you. Stay curious and keep learning.